Every morning, somewhere across America, approximately 130 million individuals consume bread for breakfast. Toast, a sandwich, a bagel, something baked, sliced, wrapped in plastic with a sell-by date 3 months away. And here is what nobody sitting at that breakfast table is discussing. That bread, the one resting on your counter since you can remember, may be doing something to your colon that a gastroenterologist cannot remedy with a pill, a procedure, or a follow-up appointment. Not slowing something down, actively dismantling the one biochemical system your body relies on to shield itself from colorectal cancer, the second deadliest malignancy in the United States, every single morning. The system earns money when you remain unwell, not when you recover. What I am about to reveal, nobody is going to bring up at your next colonoscopy preparation appointment, and I want to be straightforward with you about the reason. It is not because your gastroenterologist does not care. It is because what I am going to describe requires 8 minutes to understand properly, and the average office visit gives your physician 12. The arithmetic does not work in your favor. Honestly, when I first examined this data, I had to revisit it twice. I have devoted years to this literature. I have reviewed thousands of papers on gut health, cancer biology, and fermentation science. And when I encountered the mechanism documented by Dr. Marcus Donohue at the University of Texas, published in Findings from 2012, I leaned back in my chair, because the implications of what he demonstrated are not a footnote. They are the entire story. What Donohue documented is that butyrate, a short-chain fatty acid manufactured inside your colon by bacterial fermentation, selectively eliminates colorectal cancer cells through a mechanism called HDAC inhibition, while leaving healthy colonocytes completely unharmed. The identical molecule, two entirely different outcomes, depending wholly on which cell it enters. Most individuals believe cancer prevention is about avoiding harmful things. The research demonstrates it is also about nourishing your colon with the correct fuel, so your own cells handle the threat. Not supplementing, not medicating, nourishing. Even people who consume whole wheat every morning, who transitioned from white to brown bread years ago, who purchase the expensive multigrain loaf, who examine every nutrition label, are still receiving almost zero butyrate from that bread, because it is not the grain, it is the fermentation. And virtually no commercial bread sold in the United States is genuinely fermented. I am going to clarify precisely what is occurring inside your colon right now. The biology, the chemistry, the compounds operating against you in what you consider healthy bread. And then I am going to introduce you to a bread that has been performing this correctly for 5,000 years. A food that predates the Roman Empire, the Silk Road, and every nutritional guideline the USDA has ever published. I am Dr. Bennett. I translate peer-reviewed research and document the case patterns that emerge across the literature, so you encounter the evidence without the marketing layer. Before we proceed further, what I am sharing today is educational information grounded in published research. If you are currently receiving treatment for colorectal cancer, a gastrointestinal condition, or taking medications that influence your gut, collaborate with your physician before making any dietary modifications. This is not medical advice. It is documented mechanism. There is a distinction, and that distinction is significant. Your colon is not a passive tube. Consider it the way you would think of a fermentation vessel in a brewery. Active, temperature-sensitive, microbially populated, generating compounds that exist nowhere else in your body. Approximately 5 feet long, lined with columnar epithelial cells called colonocytes, and inhabited in a healthy adult with somewhere between 38 and 100 trillion microorganisms. A single gram of healthy colonic mucosa contains approximately 100 billion bacteria. More living organisms than there are stars in the Milky Way. That is not a metaphor to make you feel reassured about your gut. That is a scale that the medical establishment has fundamentally neglected to communicate to the public. Your colon is not a waste disposal system. It is one of the most biologically dynamic environments on the planet. These bacteria have one primary responsibility when it comes to your cancer vulnerability: fermenting dietary fiber, specifically resistant starch, into short-chain fatty acids. The 3 principal ones are acetate, propionate, and butyrate. And butyrate is the one that transforms everything. It is the upstream compound. Everything else is downstream consequence. When butyrate production is elevated, your colon's defense mechanisms operate. When butyrate production declines, and I am going to demonstrate exactly how modern bread manufacturing guarantees it declines, the downstream consequences are measurable, documented, and directly connected to colorectal cancer vulnerability. Here is the mechanism. Resistant starch is a form of carbohydrate that your small intestine cannot digest. It passes through your small intestine completely intact, arrives in your colon unmodified, and the bacteria there, Lactobacillus, Bifidobacterium, Roseburia, Faecalibacterium prausitzi, ferment it. The fermentation product is butyrate. Butyrate then penetrates colonocyte cells and accomplishes something remarkable. Inside a healthy colonocyte, a normally functioning colon cell, butyrate is burned as fuel through standard metabolic pathways. It enters what biochemists call the TCA cycle. It generates ATP. It keeps the cell energized and replicating correctly. Consider it premium fuel entering an engine constructed for it. But inside a colorectal cancer cell, something entirely different unfolds. Cancer cells depend almost entirely on glucose for energy, a phenomenon called the Warburg effect. They have largely deactivated their mitochondrial oxidative metabolism. They are metabolically rigid. So when butyrate reaches a cancer cell, the cancer cell cannot combust it as fuel the way a healthy colonocyte can. Instead, butyrate accumulates. It migrates into the nucleus. And then it accomplishes something that no pharmaceutical has been able to replicate cleanly at this scale without substantial side effects. It inhibits histone deacetylases, HDCI inhibition. Histone deacetylases are enzymes that silence tumor suppressor genes. In straightforward terms, they function like a lock that keeps your body's cancer-fighting systems deactivated. When butyrate blocks those enzymes, when it picks the lock, the tumor suppressor genes reactivate. The cancer cell receives the signal to undergo apoptosis, programmed self-destruction. The cell dismantles itself from within. Immune cells clear the debris, and the healthy colonocytes nearby, still fueled, still replicating correctly, still protected. That is not a miracle. That is biochemistry. That is your body executing exactly what it was designed to do when you supply it with the raw material to do it. There is also a second mechanism, and this one functions at the immune level. Butyrate stimulates the production of regulatory T cells, called Tregs, in the colonic mucosa. Consider Tregs as the immune system's peacekeepers. Their responsibility is to suppress inappropriate inflammation while maintaining active surveillance against abnormal cells. They are the checks and balances of your immune response. Low butyrate means low Treg induction. Low Treg induction means chronic, low-grade colonic inflammation that never fully resolves. And chronic colonic inflammation is one of the most established risk contributors for colorectal cancer development over time. Now here is what I uncovered was concealed in the data. The fermentation is accomplishing something nobody in industrial food manufacturing wants you to calculate. The single most critical variable for butyrate production in your colon is not how much fiber you consume. It is whether that fiber has been pre-fermented, because pre-fermentation alters the molecular structure of resistant starch in ways that make it dramatically more accessible to colonic bacteria. While this fermentation, the kind that requires 3 to 5 days, not 2 hours with commercial dry yeast, partially breaks down phytate, releases bound minerals, and generates a resistant starch profile that survives digestion and arrives in the colon structurally primed for bacterial fermentation. The bacteria do not have to labor as intensely to extract butyrate from pre-fermented starch. The yield is greater, the production is faster, the downstream protection is more robust. Commercial bread does not accomplish this. Commercial bread employs fast-rise yeast, dough conditioners, and a collection of chemical preservatives that specifically prevent fermentation because fermentation reduces shelf life, makes industrial baking unpredictable, and cannot be standardized across the kind of production volumes that a national bread brand requires. The bread that costs $6 and lasts 60 days in your pantry has had fermentation industrially engineered out of it. What remains is a structurally intact loaf with essentially none of the biological activity that makes bread nutritionally meaningful for your colon. It appears like food, it performs like food in your mouth, but in your colon, it arrives as processed starch with no fermentation history. And your gut bacteria, deprived of the resistant starch substrate they depend on, produce less butyrate. Less butyrate means less HDC inhibition. Less HDC inhibition means tumor suppressor genes remain silenced. The ingredients list of the average commercial bread loaf is causing additional harm that compounds the fermentation deficit. Potassium bromate, still permitted in the United States, prohibited in the European Union, the United Kingdom, Canada, Brazil, China, and several other jurisdictions. The International Agency for Research on Cancer classified potassium bromate as a Group 2B possible human carcinogen in 1999. It is utilized as a flour improver in commercial bread manufacturing. It fortifies gluten structure and provides bread a better rise, which is entirely a texture and appearance advantage for the manufacturer. Azodicarbonamide, prohibited in Australia and the European Union, still permitted in the United States. It is a dough conditioner, a chemical that makes dough easier to manage at industrial scale. During baking, azodicarbonamide decomposes into two compounds, semicarboxazide and urethane. Both have demonstrated carcinogenic activity in animal studies. It has no nutritional function. Its entire purpose is manufacturing convenience. Calcium propionate is the preservative that prevents mold. It is what enables a loaf of bread to sit in your pantry for 60 days without developing the fungal growth that would naturally occur if you left genuinely fermented bread on a counter for a week. Calcium propionate accomplishes its task by disrupting microbial metabolism. The problem, documented in peer-reviewed research published in the journal Nutrients in 2018, is that calcium propionate does not distinguish between bread mold and the bacteria in your gut. Oral exposure to calcium propionate altered gut microbiome composition in the study population and specifically reduced populations of butyrate-producing bacteria. The preservative that keeps your bread shelf stable is selectively suppressing the bacterial populations in your colon that manufacture your primary colorectal cancer defense mechanism. Now, I want to share a case I reviewed that made this mechanism personal for me. A woman I will call Alamitu, 68 years old, retired school teacher, originally from Bahir Dar in the Amhara region of Ethiopia. She relocated to Minneapolis in 2019 to be closer to her daughter and grandchildren. Alamitu had lived her entire adult life consuming Injera, the spongy, porous, distinctively tangy fermented flatbread made from Teff, a grain that has been cultivated in the Ethiopian highlands for approximately 5,000 years. She ate it twice daily, every day, the way someone in the American Midwest consumes bread. She prepared it at home using a 3-day wild yeast fermentation process her mother had taught her, and her mother's mother before that. In 2014, she had a routine colonoscopy in Ethiopia. Clean, 0 polyps, 0 findings. When she arrived in Minneapolis in 2019, she adapted to the American diet gradually. Injera is not widely accessible in Minneapolis unless you prepare it yourself, and the Teff flour was more difficult to source, and her grandchildren ate sandwiches and toast, and it was simpler to purchase a loaf of whole wheat from the grocery store. Within a year, her diet had shifted almost entirely away from Injera toward commercial bread. By any standard American nutritional measure, she was consuming a healthy diet. In 2022, she had her first American colonoscopy. 2 adenomatous polyps, the precancerous variety, not cancer, but the kind that transforms into cancer if left in place long enough. Her gastroenterologist removed them, instructed her to return in 3 years, and provided no dietary guidance beyond eat more fiber. Her daughter, who had been researching gut health and microbiome science, discovered the research on fermented foods and butyrate production. She presented it to Alamitu. Alamitu began preparing Injera again, 3 times weekly initially, then daily as she rediscovered her rhythm with the fermentation process. She sourced Teff flour online. She returned to the 3-day fermentation. Within 6 months, she reported changes in her digestion she described as remarkable. Better regularity, less bloating, something she could not identify precisely, but characterized as her gut feeling settled in a way it had not since Minneapolis. The follow-up colonoscopy at 14 months revealed no new polyp formation. I am not asserting Injera reversed her cancer vulnerability. I am not making a clinical claim about a case study. What I am communicating is that the mechanism is documented in the peer-reviewed literature. The timeline is consistent with what we understand about microbiome response to sustained dietary modification. Now let me tell you about Teff and why this grain in particular is the protagonist the entire mechanism has been pointing toward. Aragrostis teff, the world's smallest grain. It is indigenous to the Ethiopian and Eritrean highlands, cultivated there for at least 5,000 years. It is naturally gluten-free, and its nutritional composition is, by multiple measures, extraordinary. Teff contains approximately 180 milligrams of calcium per 100 grams, the highest calcium content of any cereal grain. Iron content in Teff runs between 7 and 14 milligrams per 100 grams, the highest of any cereal grain by significant margin. And then there is the resistant starch profile. Raw Teff contains between 20 and 40% resistant starch by dry weight. That is one of the highest concentrations of any cereal grain on Earth. When fermented for 3 to 5 days with wild yeast, the starch structure is modified in ways that increase its resistance to small intestinal digestion. More starch arrives in the colon intact. More bacterial fermentation occurs. More butyrate is produced. This is not wellness content. This is documented food science with a 5,000-year human record attached to it. Now let me give you the practical protocol. 3 steps. You do not need special equipment or a starter culture kit. You need to understand what fermentation accomplishes and replicate the conditions that allow it to happen. Step 1. Source teff flour. Widely available online. Whole grain teff flour, single ingredient. Budget approximately $8 to $12 per pound depending on sourcing. 1 pound produces approximately 4 to 6 Injera rounds, which is a week's worth of bread for one individual. Step 2. Ferment for a minimum of 72 hours. Mix teff flour with water in a 1 to 1.5 ratio by weight. 200 grams of teff flour, 300 grams of filtered water. Cover loosely with a cloth, not an airtight lid, because the wild yeast present naturally in the flour needs oxygen to reproduce. Leave it at room temperature for 72 to 96 hours. You will observe bubbling beginning around the 36-hour mark. You will detect sourness, a clean yogurt-like sourness. That sourness is exactly what you want. That is the lactic acid. That is the wild yeast doing what wild yeast has done for 5,000 years. Step 3. Cook and consume daily. A non-stick pan or large cast iron skillet works perfectly. Pour a thin layer of batter, approximately 2 to 3 millimeters. Swirl to coat the pan evenly. Cover with a lid and cook for 2 to 3 minutes until the surface is fully set and the characteristic porous bubbles have formed across the entire surface. The porous holes you observe are produced by fermentation gases escaping through the batter as it sets. They are a visual confirmation that the fermentation was genuine and active. The 3-day fermentation produces a resistant starch yield after cooking and cooling of approximately 20 to 30% of total carbohydrate content. Commercial white bread produces essentially 0 resistant starch. Commercial whole wheat bread produces approximately 1 to 2%. Injera, made from properly fermented teff, produces 20 to 30 times more resistant starch than the healthiest commercial bread on the grocery store shelf. The gap is not marginal. It is a categorical order of magnitude difference in what arrives in your colon for bacterial fermentation. Give it 30 days. The gut microbiome does not transform overnight. It responds to sustained, consistent dietary modification over weeks. 30 days of daily fermented teff produces measurable shifts in lactobacillus and Faecolacterium prosnitzia populations, the primary butyrate-producing species that correlate with the butyrate production increases the mechanism requires. Before I conclude, I need to be transparent about when this conversation ends and a different one needs to begin. If you have blood in your stool unexplained by previously evaluated hemorrhoids, consult your gastroenterologist this week. If you have unintentional weight loss of more than 10 pounds in 60 days, that warrants urgent investigation, not a dietary reset. If you have iron deficiency anemia unexplained by your diet, that requires medical evaluation. If you have a family history of colorectal cancer, screening colonoscopy according to your physician's recommendations is the foundation of your protection, and this protocol is the complement, not the substitute. Your colon is not going to protect itself if you supply it with industrial bread additives every morning for 20 years. The research is documented. The mechanism is established. The food is genuine, 5,000 years old, costs $8 a pound, and has been waiting on the other side of a 3-day fermentation for your colon to discover it. I am Dr. Bennett. Keep investigating, keep eating right.